Hi, this is Professor Sartor, and I'm wrapping up the final 10 questions on Practice Test 2, which covers Chapter 3 and 4. This question says a farmer has 1,444 feet of fencing available to enclose a rectangular area bordering a river. No fencing is required along the river. Let X represent the length of the side of the rectangular enclosure that is perpendicular to the river. Complete parts A through C. So we have our river here. This is our rectangular enclosure, and we don't need fencing along the river. We only need fencing along these three sides. So because we need fencing on these three sides, I'm going to use that 1,444 feet to put the fencing on those three sides. Now, because this figure is a rectangle, I'm able to label this side as X, and I'm going to use the remainder of the fencing along this longer side. So we have a total amount of fencing of 1,444, and we're going to take away X for one side and take away X for the other side. And so that side is 1,444 minus 2x. Then we're asked to find an area function. Area of a rectangle is length times width. So we've labeled our sides with the length and the width. So that'll be 1,444 minus 2x times x. So that's as if X is the width and 1,444 minus 2x is the length. So I can multiply that out and get 1,444x minus 2x squared. The next part says find the dimensions of the fence that will maximize the area. So the key word here is maximize. What we have here, if I rewrite this, is negative 2x squared plus 1,444x, and this is a quadratic. We know the graph of a quadratic is going to be a parabola, and parabolas are either facing up or down, and because this parabola has a negative for the leading coefficient, I know that I'm going to have a down-facing parabola. And remember that we're trying to find the maximum area. The maximum or largest y value is going to occur at the vertex of the parabola. So if we're able to find the vertex of this quadratic, that's going to tell us the maximum area. So I'm trying to take this function, which represents area. It's negative 2x squared plus 1,444x. I'm going to use the vertex formula, negative b over 2a. My b is 1,444 over 2 times a. It's going to give me negative 1,444 over negative 4. So that gives me 361, and the units on this one are feet. So having length, I guess this is x, having one side being 361 feet gives us a maximum area. We need to find the other side as well. The other side is 1,444 minus 2x. 1,444 minus 2 times 361. And that gives us 722 feet. So we've got the side that is perpendicular to the river being 361. The side that is parallel to the river is 722. Both of those units should be in feet. And then we can find that maximum area We can do it one way by multiplying the length times the width. That's 361 times 722. So that's 260,642. And the units there are feet squared. Or alternatively, you could also substitute 361 into that area function. And you should get the same value of the 260,642 square feet. Thank you for checking out my videos. Have a great day.